Okay, can see textbook.
Can.
Okay. Remember these two questions? Okay, under discussions. Okay, A I have done for you. B and C I asked you to do as homework. Okay, we will discuss the answer now. Okay. Anyone want to give the answer for the B? Yeah, I should already give the marks, if anyone can do the questions. You can give B or C, either one. Okay. Just type on B, the answer is what? C, answer is what? Or don't know how to do. No response, I don't know is what.
N is 4.
Vanessa is what?
B. N is 4.
B, N is 4. Yes, correct. Okay, who else want to answer for C? Vanessa, you don't answer for C anymore. Right. Okay, please say, okay, for C, N is 4. Okay, now I want to make a survey. I don't know how you do it, or the full solution got or not. Got sure these questions or not. Someone referring to the full solutions? This is a 4.
Full solution got discussion.
Huh?
Full solution got for the discussion.
I'm not sure. Hey, you are critical, right?
No, Vanessa.
Oh, you Vanessa. So nobody check Then how you do? Okay, and then we see lah. This way easier. Okay, how many cannot do? Okay, put out your hand. Okay, raise out your hand. Okay, how many cannot do B? One hand? One hand saja kah? Okay, two hand. Oh, okay. Two hand saja. Two cannot do saja. The rest all can do 5, 6. Okay, 7. Okay, put down your hand. Siti Farah, Shahira, put down your hand. Okay, now C. How many cannot do? Okay, raise out your hand. Just now B got 8. Now C got 5 only. Means C is easier. I don't think so. C also look like difficult. Okay, now I try to do it. Okay, and then for those can do, if you see your answer is different from mine, then we come to discuss. Okay. So, we start with B. Okay. So the n plus 2 P3, this one I follow the definition. It will be n plus 2 factorial. Okay, and then divide by the n minus r. So it's n plus 2, this one minus r. Okay. Okay. So I'm referring to this formula, NPR is n factorial over n minus r factorial. I'm referring to this formula. Okay, so equals to 30n. Okay, first step. Okay, next this one n plus 2 minus 3, so n minus 1. Okay, the n minus 1 don't move to the right hand side first, because I'm going to simplify by using the n plus 2 factorial. Okay, so same thing, list out. Okay, which one is bigger, n plus 2 or n minus 1? Okay, you list out from there. So n plus 2 is bigger than n minus 1. So you list out from the n plus 2. Okay, the first one is n plus 2, then minus 1, continue minus 1, continue minus 1 until you list out and when you see n minus 1 factorial. Okay, so n plus 2 minus 1 is n plus 1. Okay, minus 1 is n. Okay, minus 1 is n minus 1. Here you stop, then factorial. Okay, so n minus 1 factorial at the denominator, cut. Okay, equals to 30n. Okay. Now, this one you got to expand. Okay, after that move the 30n to this side. Okay, and then factorize. Okay, so n I leave it first. So these two I expand first. Okay, so n squared. 2 times 1 is 2. Okay, 2n and 1n altogether 3n positive. Okay, minus 30n. Move to left hand side equals to 0. Okay, then the n expand. Okay, times inside. So n to power 3. And then 3n to power 2. And then 2n and then minus 30n. Okay, this one can simplify. Not simplify, sorry, combine. Okay, so 2n minus 30n is a negative 28n. Okay, then here every term got n, you can factor out n. So this one become n squared 3n minus 28. Okay, then here, okay, you do factorization. 28 is 4 and 7. Okay, and then positive 3n, so bigger at the positive at the bigger number. So here positive, here negative. Okay, 7n minus 4n is 3n, correct? Okay, therefore your n is the n is 0, 4, and negative 7. Okay, so here n we don't take negative 7. Okay, so you got to reject. Okay, and then we don't take 0 also is because the original question is n plus 2p3. Okay, if you replace the 0 here, then it will become 2p3. Cannot, This number must bigger than this number or equal. Okay, then smaller cannot. So these are also rejected. Okay, so only one answer here, n is 4. Okay, anything to discuss? Vanessa, you do the same way or not?
Yeah, yeah.
Yes, ah?
Yes, teacher.
Okay. Others, if nothing, then we go to C. Okay, see how we do C. Okay, C, the question is n plus 1, P4, 10, and then NP2. Okay, this question even more complicated actually. Okay. So same thing, we follow this definition. Okay, so we write out in a factorial form. Okay, so n plus 1 factorial. Okay, then divide by n plus 1, then minus 4 factorial. Okay, 10, write back the 10. Okay, np2. Okay, so n factorial, and then n minus 2 factorial. Okay, so same thing, how we don't move the denominator to the other side. Okay, then we try to simplify first. Okay, before that, this one I can simplify first. Plus 1 minus 4. So minus 3. Okay, this one I can write first, maybe. Okay, so n and n minus 2. Okay, so n is bigger, so I start with n. So n times minus 1, so n minus 1. Okay, minus 1 again is n minus 2. Okay, this is what you have in the denominator, so you stop. Okay, then here you can cut. Okay, so right hand side you have done the simplifications. Okay, look at the left hand side. N plus 1 and n minus 3. So n plus 1 is bigger, so you start with n plus 1. Okay, minus 1 is n. Minus 1, n minus 1. Minus 1 again, n minus 2. Again, minus 1 again, n minus 3. This is why I say this is difficult, because you will end up with n to power 4. Okay, here cut. Okay, here I expand first. Okay, 10n times n, 10n squared. 10n times 1, 10n. Okay, here, how you want to expand? Maybe I do this one, these two, okay, and then these two. Okay, then after that, join them up. Okay, so n times n is n squared. Okay, n times 1 is n. Okay, then for these two, n squared. Negative become positive. 2 times 1 is 2. Okay, this one is a negative 1n, negative 2n. Sorry, negative 2n. So it's a negative 3n. Okay, then expand one by one. Okay, n squared is n to the power 4. N squared, and this is negative 3n power 3. This and this is a positive 2n squared. Okay, second term with our other terms. Second term, okay, this is n to the power 3, negative 3n squared, and then plus 2n, okay, minus 10n squared. Okay, these two terms move to the left, plus 10n equals to 0. Okay, now group the like terms. So n to the power 4, 3, 3. Okay, no more. So minus 3 plus 1 is a negative 2 n to the power 3. Power 2, power 2, power 2. So 2 minus 3, negative 1. Negative 1 minus 10, Negative 11. Okay, next this and this. Okay, so 12 and okay equal to 0. Okay, next you check. Okay, this one all you have a terms of 1n, so you take out the n, so it reduce become a cube. Okay, and then here I don't want to teach okay how you get this, you just use calculator. Okay, so I will show you how to use a calculator to get the factor. Okay, I'm not sure, I don't know how to use it. Equation number 5. Okay, your black color calculator, same thing. You call for equation. Now you have here, you see x to the power 3. So for your equations, you choose unknown is the arrow to the right, and then you choose the after unknown is what? Okay, you take out your calculator. For those are using the black color one. You press okay, mode 3 times. Wait, 1, 2, 3. Okay, 3 times equation for 1. You put in 1. Okay, when you show unknowns, you put the right hand side arrow. Then they ask degree, here you put 3. Then they will start to ask you the A, B, and the C, and the D. Okay, so here this one is the A. This one is 1. Here, this one is the A, and then this one is the B. This one is the C. This one is the D. C and D. Okay, so you can start to put in ABCD. Okay, if silver color one, you just here you choose 4. Okay, same thing. The A you put in 1 equal. Okay, then the B put in negative 2. Okay, C you put in negative 11. Okay, then D you put in 12. Okay, so the first answer is negative 3. So n plus 3. No? This one I think you know already. Okay, second answer is 4. So n minus 4. Okay, and the third answer is 1. So n minus 1. Okay, so you have answer n equals 0, the first one, negative 3, and then 4, okay, and then 1. Okay. Okay, but the problem is which one you accept. Okay, this one assuming the answer is 4 lah, Okay, so we want to see why you don't accept 0 and 1. Negative 3 confirm no lah, because it's negative. Unless you know, because the given here is m plus 1 p4 and then n p2. Unless here is a very big number, it's enough for you to minus a 3 already, is still positive. But definitely this one is cannot, because this is negative 3, cannot negative. Okay, so this one reject. When this n is 0, 0 plus 1, this is 1p4, also cannot, because this one must be bigger than this. The n must be bigger than r or equals to. Okay, so this one also reject. Okay, how about this one? N equals to 1. Okay, 1 plus 1 is 2. So also cannot, because it's still smaller than R. Okay, so this one also rejected. Okay, so N equals to 4, the answer. Okay, I guess I'm not sure whether you are using this method. Maybe, okay, some of you when you have here, I use another color. Okay, n and n minus 1, n and n minus 1, I think so you already cut this away. You already cut this away. Okay, then your holding will become very simple. Okay, so easily you can solve your equations. But actually, it's not correct. It's because if you are using this way, you're going to miss two answers. Okay, from 4 answers, you're going to miss 2 answers if you're doing this way. Okay, cut away the unknown at the beginning. Cannot. You can you can simplify the number only, but not simplify the unknown. Okay, if you do in that way, remember, if you do is in this way, you will cut down your number of solutions. Okay, even though the 2 solution at the end you don't accept it, which is a 0 and 1, but you still have to show it. Okay. Okay, any questions? If exam like that come out, die loh. Okay, any questions for the homework given? Diam saja. Diam berisi. Baca.
4.5, number 2.
4.5, number 2. Correct? Okay, wait. 4.5, number 2. Okay, this is page 113. Okay, these questions find the number of way of a 4-digit number greater than 2000 to be formed by using the digits without repetition. Okay, without repetition. Okay, 4 digits. 1, 2, 3, 4. 4 digits number greater than 2000. Okay, so what can put in the first digit if you want this whole number bigger than 2000? So you cannot put 0. You can put 2. Okay, and the rest also. Okay, so you can put in 2, 4, 5, 6, and 7. Once you put 2 here, it doesn't matter whatever you put at the back, it will still it will become bigger than 2000. Okay, so for the first digit, there is 5 choices. Okay, then after you choose 1 digit put in already, here got how many number? 6 number. Okay, so once you choose 1 to put in already, 6 minus 1, so you left 5 choices, then continue 4 choices, and last is 3 choices. So this is the answer. Okay, 5 times 5, 25. Ayo, how to clear all this calculator? Anyone? Clear all. On? No? Off? No? Off. 姐會，唔會姐。哎呦，死了啦！ How? Anyone know how to use this calculator to clear all? Black color, yeah lah, clear all lah.
Teacher, mode 1.
Yeah. Put what? Mode. Then?
1.
1. That's all. Oh, thank you.
Yeah.
Okay. 25, then times 12. Okay, so 300. Is my answer correct, Melissa? Or others? Do you get the same answer like mine? Answer my question first. Is my answer correct? Anyone? I just
Yes,
need
teacher.
one. Okay, thank you. Sophia asked, teacher, how many marks do this chapter contribute? Sophia, you don't want to do these questions? Normally, because after you still have a combination. So permutation combinations are normally, but this is old syllabus law. Old syllabus there, they always come out in paper 1, like got 2 questions. They say one question is 3 or 4 marks lah. So all together will be like 7 marks like that lor. Sophia, okay?
Thank you.
Okay, so got some more questions to ask? I count 5. 5, 4, 3, 2, 1. Okay. Today we have 3 periods, right? So we have another hours. Okay, so we continue the lesson. I think today I can finish the whole topics. Okay, combinations. Okay, so combinations. You write the index for today. Combinations. 21st. Okay, first of all, we want to compare permutation and combination. What is the difference? Okay, you see here, permutation, you have learned that the position of each object in each set is important. For example, the arrangement AB and BA are 2 different arrangements. Okay, then for combinations, AB and the BA are the same. Okay, that's simple only. Okay, for permutations, the position is important. For combination, position is not important. Okay, we look at this problem. Okay, let's say you have 3 friends, Keith, Wong, and Shelby. Okay, you need to choose 2 out of your 3 friends to join you in a kayaking activity. How many ways can you make this selection? Are your friend's position important in this selection? Not important lah. Okay, just jump into a kayak only ma. Okay, so the position actually is not important lah. Okay, if you think that the position is important, then you got to do permutation. No? Position is not important, then you do a combination. No? Okay, we see a permutation first. Okay, let's say the position is important. By using a tree diagram, we can list out all the possible choices. Okay, so means what? We start with Akif. If you choose Akif, then the other one you can choose either Wong or Selvi. Okay, if you choose start with Wong, then Akif Selvi. Then if you start with choose with Selvi, then it's Akif and Wong. Okay, so all together 1, 2, 3, 4, 5, 6, 6 choice, 6 possible arrangement. No? Okay, however, is the decision to choose Akif and Wong different from choosing Wong and Akif? This one and this one. Okay, now they ask, is these 2 same or not? Okay, you just jump into the kayak lah, so we just say like that. Okay, the arrangement is not important. So Wong and Akif or Akif and Wong, these 2 are the same selection, we can say. Okay, so then you will see this and this is the same. Then one more, you will see this and this is the same. Okay, so therefore now you only left 1, 2, 3. Okay, 3 selection. Okay, In the above situation, is the position of an object important in making the choice? Okay, based on the diagram on the right, there are only three ways to choose since the position of object are not important. Okay, hence the position choices are this, and this. So become three selections. Okay. But I say lah, okay, Akif Wong and Wong Akif is the same. Okay, Akif Selvi, Akif is the same. Wong Selvi and then Selvi Wong is the same. Okay, when choosing an object from a set where position or arrangement are not important, the selection is called combination. Okay, this one you can copy as your notes. Okay, positions, arrangement are not important. Okay, combination. So I will look at this, okay, so you don't have to do as homework, okay. State whether the following situation involve permutation or combinations. Explain it, okay. A television station company offer to its customer, or example Astro, okay, offer to the customer a selection of 7 channels from 18 available channels. So is the arrangement that you choose a 7 channel is important or not? Okay, how? Someone answer my question. Is the arrangement, arrange the 7 channel important or not? Someone? Okay lah, no need call someone, I call Farah. Farah here? Okay, answer my questions. Is the arrangement of the 7 channel important or not? Okay, thank you. Okay, the arrangement is not important. Okay, so I give you 1 mark. Then they got people answer my questions. Okay, so this one the answer is no. Okay, the arrangement is not important, therefore this one is involved permutation or combination. Okay, next girl. Next. Kritika not here. Lydia. Lydia here. Someone please check the list. I can't see my list. Lydia here. Yeah, she's here. What? Oh, Lydia. hello.
Teacher, check the chat box.
Oh, yes, so fast. Okay, can you please answer? Okay, Farah just now say the arrangement is not important in this question. Can you tell me, so this is involved with permutation or combination? Okay, combination. Thank you very much. Okay, we come back here. Okay, so this is combination. Okay, how to explain is you just say long because the arrangement is not important. Why blinking? Why blinking? What's happening? Why blinking? What's happened? Yeah. Oh, sorry. I accidentally not purposely accidentally I don't know how to delete it. I don't know how to relate it. Accidentally, Lydia, don't get angry with me. Okay, continue. Okay. So this one, it doesn't help you to calculate yet. Okay, just want you to know this is combination, not permutation. Okay, one more example is here. You can see the difference of these two, okay, so that you will know which one is permutation and which one is a combination. Okay, permutation, okay, is a process of arranging objects which order and sequence are taken into consideration. For example, okay, choosing 2 out of 5 pupils for the class leader, okay, for the class leader and assistant class leader positions. Then this one arrangement is important because class leader, you can choose A be the class leader, and then you choose B for the assistant class leader. Then you can choose B as a class leader and then A as assistant class leader. Okay, so they are holding different position. Therefore, the arrangement of the position is important. You got to do permutation. Okay. Okay. How about this? Okay, combination. Okay, it's a process of selection without considering the order and sequence of the object. For example, okay, choosing 2 out of 5 pupils to join a competition. This one the position or the arrangement is not important. You just out of the 5 people, you just grab 2 people and join. Okay, like just now I say, okay, I choose A and B, okay, to join the competition. It's no matter, it doesn't matter the A I choose first or the B I choose first. Okay, so if I say I choose AB and I choose BA, actually is the same thing. Okay, that one is considered one. Okay, one combination only. Okay. So I hope you all can differentiate what is a permutation and what is combination. Okay, we go to next. Okay, now we want to see how to count the combinations. Okay, determine the number of combination of R object chosen from n different object at a time. Okay, so this is NCR. Okay, then we have a NPR. So this is an NCR. Okay, from n object you choose a R object. Okay, we use that almost the same example like just now, okay. Okay, but I write it ABC is easier lah. I don't want to use this. This one got 4 object. Okay, I use a more simple one, ABC. Okay, so ABC. Okay, how do you choose? Okay, let's say the arrangement is important, Okay, so we will start with AB. Okay, then SC. Okay, then we will start with B. So it's BA. Okay, BC. If we start with C, then it's CA and then CB. Okay, so all together 6. Okay, how do you get 6? Okay, if you use a permutation, okay, it's a 3, you choose 2. Okay, so you get is 3 factorial and over 3 minus 1, 1 factorial. Sorry, 3 minus 2, okay, 1 factorial. So you get the answer is 6. Okay, 1, 2, 3, 4, 5, 6. Okay. Now, okay, the arrangement is not important. Therefore, this and this the same. So this is only considered as 1. Okay. This and this the same. This one again is considered as 1. And then this and this the same. Okay. So this one is considered as 1. So you can see the 2, every 2 is considered as 1. Therefore, this answer, the 6, you got to divide by 2. Okay, so altogether 1, 1, 2, okay, and 3. Okay, 3 combination only. Okay. So this is how you get the answer. Okay, by using the formula. By using the formula, you can see, okay, NPR. Just now, I'm using NPR at first, the 6 one. Okay, then divide by the 2. The 2 is from here. Okay, the 2 is actually 2 factorial. Okay, so your formula is NPR, okay, over r factorial. Okay, so this one you copy okay, as your notes. Okay, NCR is equal to NPR, okay, over r factorial. Okay, and then NPR itself is n factorial over n minus r factorial. Okay, then with the r factorial. Okay, so this one you have to remember. Okay, same as a NPR. Sometimes they will use the NCR, ask you to do in unknown. Okay, so this one you've got to remember. Okay, we see this. Okay, combination can be written as NCR or okay in this form in bracket NR. Okay, NCR is also known as binomial coefficients. Okay, why it called also binomial coefficients? If you see on the next chapter how we're going to do probability distributions. Okay, next week we're going to do this. Okay, probability distribution. Probability distribution same thing. There are two parts. One is binomial distribution, and then one is a normal distribution. So I think next week we can do a binomial distribution. But normal distribution I think tak sempat tu. Okay, that one will be after holiday already. Okay, therefore afterwards when you see the binomial distribution, again you will see this NCR. Okay, so this one is also called binomial coefficients. Okay, how about this? Okay, prove that NC0 is 1 and NC1 is equals to n. Okay, n is a positive integer. So when you want to prove this, you need this. Okay, so we will see how we're going to prove it. Okay, NC0. Okay, NC0 is what? Okay, you follow this formula. Okay, it will be n factorial. Okay, 0, the r now is 0, so 0 factorial. Okay, n minus r, so n minus 0, so it's n factorial. So cut. Remember, 0 factorial is 1, therefore 1 over 1 is 1. Okay, so I get the answer. Okay, next, NC1. Okay, same thing, follow the formula, n factorial. Okay, r now is 1, so 1 factorial. N minus r, so n minus 1 factorial. Okay, this one 1 factorial is 1, so next step no need to write it. Okay, n factorial n minus 1, which one is bigger? N is bigger than n minus 1, so I start with the n. Okay, minus 1, so n minus 1 factorial. N minus 1 factorial. Cut. Therefore you get n. Okay, this is how you get the answer. Okay, next we go to the example. Okay, look at this. The martial arts teams of SMK Sari Baru, okay, consists of 8 pupils. 2 pupils will be selected to represent the team in the martial arts show. Okay, that means the number of ways to choose the 2 pupils. Okay, arrangement is not important. Okay, who go first also never mind. So out of 8, choose 2. So very simple, 8C2. Okay, finish. Okay, you can use a calculator, okay, to get the answer. Means you can skip all this step. This one no need to show unless they say without using calculator. Then you got to show this step. Okay, 8C2. 8. C is here. Okay, so it's divide. So shift divide and then 2. Okay, so 28 the answer. Okay. Okay, 3 committee members are to be selected from 10 candidates in a club. Okay, find the number of ways to select these committee members. Okay, so out of the 10, you choose 3. So very simple, 10C3. Okay, so once you get the idea, you see can do very fast. Okay, so 10C3. Try one more time. 10C3. So 120. Okay, if you have calculator with you, try and see. Make sure you know how to use a calculator to get the answer. Okay, so this one is same thing. This one no need to show. Okay, unless you say cannot use calculator, then you got to use this way lah. Okay, find the number of triangle that can be formed from the vertices of a hexagon. Okay, hexagon got 6 vertices. 6 vertices. So it means out of the 6, Okay, triangle got 3 vertices. Okay, so out of 6, choose 3. Okay, so 6C3. Okay, let's try 6C3. Okay, 20. Right. 20 is the answer. Okay, so this one will be your homework. Okay, this example is with conditions. This one is more complicated already. Okay, so you have conditions here. Consider the situation below. A class monitor wants to divide your 10 friends into 3 groups of 2 peoples, 3 peoples, and 5 peoples. Okay, 3 groups. Okay, the first group got 2 people, second group got 3 people, third group got 5 people. So altogether, 2 plus 3, 5, 5 plus 5, 10. So these 10 friends are equally, not to say equally, sorry, how to say, means after you divide into group, no balance. Okay, find the number of ways that grouping can be done. Okay, so you see, to solve a problem which involve combination with certain conditions should be dealt with first. Okay, so the first one is 2 students, 2 people. Okay, so means you can choose from 10. We start with 10. Okay, 10 choose 2. Okay, so this is the first one. 10 choose 2. Okay, after you choose 2 to form the first group already. Okay, the 10 people, you left 8 people. Okay, so now you to form the second group, which has 3 people. So 8 choose 3. 8 choose 3. Okay, 8C3. Then after that, okay, out of the 8 people, you choose 3 already. The balance is 5. Okay, so this is for the last group. Okay, so 5 choose 5. 5C5. Okay, then in between is times. You have 45 times 56 times 1. Okay, 45, 56 times 1. So this is the answer. This question is always have this kind of questions come out on. Okay? Even the 2020 paper also got one very similar questions come out. Okay. Okay, look at this. If you choose either 5 people first or 3 people first, well, you get a different answer. Compare your answer with your friend. This is very good. Let us try. Let's say I don't want to choose to form the first group that have 2 people. I want to form the first group got 5 people. You will have the same answer or not? Okay, let us try now. Okay, let's say I want to follow this sequence. I choose the first group is 5 people, then 3 people, and then 2 people. I just do one more compare. Okay, then the rest are up to you. You want to try or not? Okay, so the first I choose 5 people to form the first group. So start from the 10 people. I choose 5. After choose 5 already, okay, 10 minus 5, I got balance of 5 people. Okay, then to form the second group, 5 people choose 3. Okay, then 5 people you choose 3 already, 5 minus 3, you have balance of 2 people. Okay, last group is 2 people, so 2 choose 2. Okay, let us try. Then apa macam? Then C5 times 5 C3 times 2 C2. Okay, 2520. Is the same answer? Okay, 2520. Same answer. So doesn't matter which group you form first. Okay, you will get the same answer. Okay, okay, look at these questions. Same thing, have conditions. Okay, a football team is made up of 17 local players and 3 foreign players. 17 local. Okay, 3 foreign player. Okay, a coach wants to select 11 key player, okay, to compete in a match by including 2 foreign player, Okay, find the number of way to select these 11 player. Okay, so how? The 3, okay, you choose 2. Okay, so this is the first 3, you choose 2. Okay, times. After that, after you choose 2, the 11 player that you want to choose, you already chosen 2, so 11 minus 2. Okay, so you need to choose some more 9. Okay, the 9 is come from the local player, okay, which is altogether 17. Okay, so this is how you get this. Okay, then just press calculator, you get this answer. I think something wrong here, should be times not equals, huh? Okay, go to these questions. Okay, NJ, Samad wants to choose 3 types of batik motif from 4 organic motif and 5 geometrical motif. Okay, find the number of ways to choose at least 1 organic motif and 1 geometrical motif. Okay, so must have at least 1. Okay, so if not at least 1 means you can don't choose at all one of these. Okay, let's say if you don't have these conditions, you can organic, don't choose at all. Okay, all the three you choose from a geometrical, or all the three you choose from organic. Okay, no need to choose at all the geometrical motif. But here you have to follow this condition: at least 1 organic and then 1 geometrical. Okay, so you want to choose 3 types. Okay, at least 1 organic and at least 1 geometry means what? It can be 1 organic and then 2 geometrical. Okay, it can be 2 organic and then 1 geometrical. Okay, it can have 2 situations. Okay, if there are 2 different situations, in between is plus. Okay, here the in between is times. This one you got to be very clear. Okay, so we start with this: 1 organic and 2 geometry. Okay, so 1 organic, you have 4 organic, 4 choose 1. Okay, so 4 choose 1. 2 geometry, okay, is from 5 geometry, you choose 2, so 5 choose 2. This is one way. The other way, so in between is plus. 2 organic, okay, 4 organic, you choose 2, 4 choose 2. Okay, and then 1 geometry is from 5. Okay, so 5 geometry, go and then you choose 1. Okay, so in between is plus. Okay, so this is the answer. 4C1, 5C2, 4C2, 5C1. Okay, in between is plus. Okay, so answer is 70. Just press calculator lah, you get the answer. Okay, so this one will be another homework. Just now 4.7, 4.8, and then plus this. Okay, so 3 homework today. This one I will do for you. Okay, so when you do, you can copy from my answer. Show this. Know how to show it. Okay, let's try. Okay, it say that by using the formula NCR, Okay, sure, this one is equal to this one. Okay, not difficult. Okay, this one itself from this formula is this. Oh. Okay, therefore I just need to show the right hand side one is equal to this formula, then settle. Okay, so I start from the right hand side. Okay, you follow this formula. Okay, so n factorial. Okay, m minus r means this minus this. So m minus r must put bracket. Okay, factorial, and then times r factorial. R now is this. So m minus r factorial. Okay. Okay, expand this n minus n. Okay, negative become positive r. Okay, I continue here. Okay, n minus n is 0. Okay, so left r factorial. N minus r factorial. Okay, same. This one and this one the same. Okay, therefore you can write is equal to NCR. Okay, equals to left hand side. Okay, shown. Okay, not that difficult lah. So, any questions for me? Okay, we have finished this chapter. Habis. Okay, so next week we can start chapter 5, probability distributions. Then chapter 6 and 6, trigo is a bit difficult. Okay, and then last two topics 7 and 8, that two is how to say, is the selections in paper 2 section C. Okay, I think it's still the same lah. If the old syllabus they make it that way, your from 4 last two chapters and the from 5 last two chapters. Okay, 4 chapters altogether. Is the selections questions in section C. Each chapter will give 1 questions, 10 marks questions. So the four questions you choose 2 questions to do. Means these 4 chapters actually you can choose 2 chapters to concentrate with. But if possible if you can cope actually, or you must try to at least the simple question you can do is because 4 out of the 4 questions is sometimes they come out some questions are difficult that you aim to do. Mana tahu come out is a difficult questions, then rugi lor. Then at least the 4 topics also, if you cannot concentrate in all 4 topics, maybe out of 4 you choose 3 at least lah. Okay, so that you have a difficult questions in one of the questions, at least the other 2 you still can do lor. Okay, if you only concentrate on 2 chapters then it's very risky lah. Okay, so you see 7 and 8 is the selective topic lor. So that's all for this syllabus. Okay, for Form 5 syllabus is very short. Okay, until chapter 8 only. Okay, so chapter 5, next week I try to finish binomial. Okay, when the school open, okay, normal distribution, and chapter 6 trigo. Then we have 7 and 8 linear programming, which is you have learned, I think so, in your modern maths, some of it. Okay, linear programming, and then kinematic of a linear motion. Okay, last time we call it motion along straight line. Okay, for you to do a kinematic of a linear motion, your dy dx, your integration, your differentiation must be good lor. Okay, if your integration differentiation cannot do, then this topic will be difficult lor. But all the function they give is all very simple. You normally you don't have to use product rules, quotient rules, chain rules, normally no need. Okay, all are very straightforward differentiation and integration. Okay, so if you can handle the simple differentiation, integration, this kinematic of a linear motion also you can do. Okay, any question for me? Okay, I assume no question lah. Okay, I will stop our recording.